Hi everybody, welcome to exercise testing again. I'm your TA, Robert Lewis. Today we're going to be going over how to enter underwater data. Okay, so we collected the data today. You should have received the scanned printout sheet that I sent a little bit earlier today, and you should have that on hand. We're going to start from ground zero as usual. The email that was sent to you guys has several attachments. Last time we went over anthropometric calculations. This time we're going to go over underwater calculations. Okay, so go ahead and download that, open it up, and that'll bring you to a sheet like this. Now for the data, I'm not going to use split screen this time since there's a lot more going on. So go ahead and have your sheet handy. The example that I'm going to be using is from Master 1 1230 class. I'm going to be using Wyatt Bear, WB, as my example subject. Okay, so you should be starting with a sheet that looks just like this. We're going to go ahead and start entering information from left to right. We're going to start with his initials, so WB. Weight in pounds is 152. And you notice automatically changes the weight in pounds to kilograms. This one isn't quite as nice as the anthropometric data because it's not super clear which cells have the equations in them and which don't. So make sure you pay attention as to which things that I'm filling in here. Okay. Now RVBTPS, we are not provided with that. However, what we're going to do is I will help you guys create a formula for that on the right hand side once we're done entering all the rest of the data in. Okay. So hang tight with that. We're going to scroll over to the left. Notice tare weight is 2.7. Make sure you don't change that. That's what the weight was that we put on your waist when we weighed you underwater. Water temperature for this class was 35 degrees Celsius. So I'm going to put 35 in there. And you'll notice the density of the water shows up automatically, so no need to do anything there. Underwater weight 1, 2, and 3 here. So there's 3 different options. And for most of you, I only did 3 measurements. However, there are a couple of you that did 4. If you did 4, just take the 3 closest ways. So if, for example, 3.6, 3.2, 3.1, and 3.4, go ahead and choose really between any of them. We can do 3.1, 3.4, and 3.2. Okay. So for Wyatt, though, we only did 3 ways. It was nice and steady. So we're going to do 6.2 in the first cell, 6.2 in the second, and 6.3 in the third. Okay. All right. So this is already filled in. We don't have to do anything with that. The weight minus the tare underwater weight is what is in this cell here. That's tared underwater weight. Okay. Body density is automatically filled out. That's the equation for you there. It's 1.050421. Okay. You'll notice, as usual, we want at least 5 decimal places. If you have a little bit more, that's no big deal. Just don't report them on your lab report. All right, so let's move on to the right and see what we get. We've got 21.24 for the percent fat here. Fat weight, we've got 14.64. For the fat-free weight, we've got 54.30. Now let's back up here just for a second. I want you guys to notice, if any of you know Wyatt, you know that he's a very lean individual. He's a gymnast for Nebraska, and there's no way he has 21.24% body fat. Now the reason for this number is that we have not yet filled in RVBTPS. Okay, so that's very important, which we're going to take care of in a second here. But Wyatt, don't freak out. Your body composition is not 21.24. And make sure for the rest of you guys, when you're entering these data in, that you include the RVBTPS. Otherwise, we'll get a pretty skewed result here. All right. So fat weight, we've got 14.64. Fat-free weight, we've got 54.30. And note that these are in kilograms. If you add 54 and 14, you get the weight in kilograms of the individual, not the weight in pounds. Okay. Then we have the fat weight with the Brozek equation, which is 20.86. Fat weight Brozek 1 and This is the body fat percentage with the Brozak equation. I'm sorry about that. This is the fat weight with the Brozak equation. And this is the fat free weight with the Brozak equation. Okay, so let's take care of that RV. Okay, so let's go to the right here. And we don't want to enter this equation in on the left here at all, because a lot of these equations are dependent on which cell these values are located in. And if we add a cell into one of these columns, or if we add a column, that's going to screw things up with the equation. So we want to make sure we're out of reach of these equations here in order to enter our equation. Okay, so first thing we want to do is we'll probably create two places, one for male and one for female, because there are two constants, vital capacity or RV constants, that we'll use for male versus female. Okay, so let's go ahead and do males first. Okay, so we'll say VC, standing for vital capacity, and let's put M for male. You can label it whatever you want. Okay, you're not going to turn this in. This is just for your guys' reference here. Next column over, let's go ahead and put vital capacity BTPS. BTPS, okay? And that's going to be the vital capacity corrected for the BTPS, okay? Finally, we are going to put RV BTPS on here, okay? So we have three columns, VC, VC BTPS, and RV BTPS, okay? Let's go ahead and make these bold so it's apparent that they are the column headers, okay? All right, so first thing we're going to do, we're going to enter the raw vital capacity value for Wyatt, and that is located on the next page, the page right after the underwater weighing values. You'll see vital capacity for number 1. His vital capacity highest score was 3.9. Okay, so let's go ahead and put that in, 3.9. All right, that was easy enough. Now, we want to do VC BTPS, but what we're going to do is we're going to create an equation so that we don't have to go through and multiply each individual score. All right, the way we're going to do that for creating equations, first you want to start off by entering an equal sign. That tells Excel that you are about to create an equation. Okay, so we're going to put an equal sign in. Then we're going to do a open parentheses, and we're basically going to create our equation. So what is our equation? Well, for males, we take the VC BTPS correction factor, or excuse me, we're finding the VC BTPS. So what we're going to do is we're going to take the vital capacity and we're going to multiply it by the BTPS correction factor. Now, although the room temperature was not written on this particular master, okay, we're going to use a room temperature of 24 degrees Celsius, which gives us a BTPS correction factor of 1.080. Okay, that's what we're going to use for every class. Okay, so whether you're in my first section or my second section, doesn't matter. We're going to use 1.080.